Thank you very much for allowing me to speak this evening. My name is John McCawley. And we're going to be talking a little bit about microservices, which is kind of a topic, it sounds kind of strange, which is near and dear to my heart. So forgive me a little bit. Hi, how you doing? Forgive me a little bit as I go through this. This is a new clicker to me, so I'll try to do my best. Tonight what we're going to do is we're just going to go through a brief introduction of microservices, an introduction of myself, and then a brief definition of microservices, what it is. I'm not going to spend a whole lot of time on it in the initial stages, but we'll get into more depth as we go through the presentation. Then I want to talk a little bit about the benefits of microservices, and probably during that discussion we'll talk a little bit about the pitfalls and the downfalls of using a microservices architecture or microservices pattern. And then I want to talk at a very, very high level about the principles of good execution with microservices, and basically what we're trying to accomplish and some of the ways that we can do that at a very high level. And then I'm just going to conclude it with some information and some research material if you're interested in microservices, some places that you can go to find out more about it in terms of how to implement and best practices and those types of things. Okay? I'm going to try to keep the presentation to about 30 minutes, but I'm more than happy to take questions and answer questions during the presentation, and we'll just try to keep it light and in the form of a discussion. All right? Okay. So let's move forward. I'm John McCawley. I'm the co-founder. Jody Madala is a co-founder of Digital Garage as well. I'm not going to spend a whole lot of time on my bio. The one thing that I want to talk to you about is a little bit of the stuff that's not up here. This is going to tell you that I'm an entrepreneur and blah, blah, blah. That's not really how I view myself. I've viewed myself for the last 20 years as either a software engineer or a software architect. I just happen to be lucky enough to have had the flexibility over the last 10 years to get a little bit closer to the code and a little bit closer to my development roots, and so I really enjoyed that. That's what Digital Garage is all about for me, is really working with developers and the development community and forwarding some of these concepts and thought processes that are kind of new to the industry that I think will make a huge impact on the industry. And microservices is one of those. The Digital Garage is a new company. We just formed here in New Mexico, and I'm very proud of that. I think that it's a company that has a lot of potential, and I think it has a lot of potential to change the landscape as it relates to technology in New Mexico. And so that's one of the things that I'm working very, very hard to do is keep the company here and develop it for the benefit of us all. Okay? All right. So. First of all, let's start talking about microservices. How many of you are familiar with microservices or have done anything with microservices? Great, excellent. And so are you then also familiar with Docker, right? And Kubernetes? Okay. And then what about the platforms that are kind of running Docker and Kubernetes right now? We've got Cloud Foundry as one of the platforms out there. OpenShift is another one. There's a few others as well. If these are new terms to you, don't worry about it. We're going to go into those in a little bit more depth and why we use them and so on and so forth. But it's good to see that we've got some folks here that are at least aware of them or have used them in the past. Yes?
Will you be taking notes, or will there be slides available?
No, we could absolutely make the slides available, all of the information. Jody, how are we going to do that?
And also, we're recording the presentation, so that'll be available through the incubator. I guess Sean can email it around to the group.
Sure.
And then we'll have it also on our LinkedIn website, which is just up on the wall there behind John.
Yeah, but please don't take notes unless you get off on that kind of thing, and you know. But and I'm happy to talk through this. So first of all, a definition of microservices. As you can see, this definition, I love this definition because it's so simple and vague, right? Small autonomous services that work together, right? And then we bolded autonomous and work together, right? So essentially what we've got is a system of smaller services that are working together. There's a lot of stuff that's been left out of this definition. How big are the microservices? You know, how do they communicate with one another? Those types of things. But that's one, I think, of the beauties of this particular definition, because it really kind of lets you guys know that microservices as an architectural pattern is much, much more of an art than it is a science. And so as we go through this, I don't want you to be intimidated by any of the concepts that are out there. It's really the thought process of creating the services in a way that really kind of fits your overall organization. But the core, the base thought process behind it is a distributed system that really has a bunch of smaller services that can be orchestrated together to create a much larger system. That's pretty simple. It's a good, simple definition, right? One of the things that has interested me about microservices, I think, is that this concept is not new, right? And I don't want anybody to believe that you know, as microservices goes through its hype cycle and the term becomes more and more important, that we're really talking about anything that is really, you know, a significantly new concept. It's not. I was in the industry long enough ago to have implemented CORBA, right? The Common Object Request Broker Architecture. How many people have worked with CORBA? Yeah, exactly. And so if you guys remember CORBA and how difficult it was to set up CORBA and ORB, right? I mean, the whole concept was really a very good concept in terms of distributed systems, but actually implementing CORBA was a nightmare. And only the largest companies ever successfully did it. In fact, as soon as SOA came along, I don't know of anybody that remained on the CORBA bandwagon. I think that pretty much we started doing our distributed systems through the concept of service-oriented architecture. And when service-oriented architecture came around, we had these large services that were usually wrapped in some sort of web service. We communicated between those services with either XML or some type of message bus or service bus or something along those lines. And SOA really became a very significant pattern for large enterprise systems throughout 2000. There's probably still a lot of companies that are still implementing service-oriented architectures today, right? So service-oriented architecture is really a very important concept. Microservices is really just the next evolution, in my mind, of service-oriented architecture. It's taking advantage of some of the tools and some of the technologies and techniques that we've got to actually start breaking those larger services down into smaller services and allowing us to get a little bit more granular in terms of the types of technologies that are there, the responsibilities of those services, and even the deployment, you know, where those deployments can happen out on the cloud or on our own infrastructure and those types of things. And so microservices is just, I mean, probably the best way to think about microservices in terms of a simple definition is just the next evolution of a service-oriented architecture, right? Probably a little bit more restrictive in terms of the technologies and the techniques that we're using, but overall I think it's probably a very, very good and very positive evolution. Any questions on that so far? Okay, so that's the real simple definition. Let me just real quickly go through why do we want to talk about microservices. So, you know, I doubt anybody is happy with CORBA architecture because it was so complex. That's fine, but I'm sure that there's a lot of people out there that are very happy with the service-oriented architecture. They may not even have a service-oriented architecture. You might have more of a monolithic architecture with layers built into it. You know, your data tier, your server, your front end, all of those types of things. That might be your architecture, and you're just absolutely happy with it. And so then the question really becomes, okay, so if I'm happy with that architecture and it's working for me, why should I be looking at anything else? And you know, if I'm a small company versus a big company, should I be looking at microservices from the get-go versus, you know, waiting until I have customers on my platform, or I have, you know, I've deployed the application or something along those lines. So what I want to do is just very quickly go into the overall benefits of microservices. I'm sure that as we talk about this, we're going to talk about some of the pitfalls as well. So in terms of the benefits of microservices, probably I think the number one thing is the thing that I have listed here, and it's probably difficult to see. Freedom to choose technology. Let's just do a thought experiment here for just a second. How many of you guys consider yourself developers, right? We're at a software developer meetup. All right, yeah, okay, good. Some of us are citizen developers, right? And some of us are you know, touch the keyboard in anger, that's fine. I am a citizen developer, right? Every once in a while, my development team allows me to write some code. They check it thoroughly before it ever goes into production, but I consider myself a citizen developer. I enjoy it. Of the folks that consider yourselves a developer, back-end developers? Any back-end developers? Okay, great. And of the back-end developers, SQL or no SQL? Is there a preference? SQL? No SQL? Okay, almost all SQL. Okay, that's fine. And the rest, I'm assuming, are front-end developers. Django? Right. Yeah, I gotcha. Yeah, good. What other technologies do we have?
Java.
Java. Okay.
C++.
Okay. Yeah. PHP.
Python.
Python. Yeah. Absolutely. Yeah. So which is the best language?
Whichever one works.
Yeah.
Each one has its own purpose.
That's right. Each one has its own purpose, right? And so that's the overall idea. Is that when we start to talk about applications, and when we start to talk about technologies under those applications, one of the things that I found out through, you know, almost 20 years in the industry, it hurts me to say that, but through almost 20 years in the industry, probably the biggest problem that I've always seen has never been, if a development team is not able to execute, it's not because the technology is wrong, although that's almost always the first place that we look. We look either at, you know, the fact that, you know, Java is hard to deploy, right? Or we look at, you know, Python doesn't have enough, you know, instructions in it, or something along those lines. And we always get into these religious wars around what is the right technology for the problem that we're trying to solve. Almost 90% of the issues are really organizational more than they are the technology side. So one of the biggest benefits to me of microservices, and I think it goes largely overlooked, is the fact that you have the ability on almost a responsibility or feature by feature basis to determine what the best technology is for that feature. If your services are small enough and they can communicate, you know, if I have a Python service that can communicate to a Java service or even a JavaScript service, right? Then I'm free as a team or a pair or a person to make a determination on what technology I want to go into that service. And I can usually choose the technology that either feels the most comfortable to me. I remember years ago when I worked for a telecommunications company, we were creating an object to relational mapping layer, and we had an absolute genius when it came to SQL, to SQL. I had never seen anybody write as much logic in a stored procedure as this guy could write in a stored procedure. It was just absolutely amazing. And nobody else could replicate it, right? But that was his language. That's what he felt comfortable with. And boy, when he wrote something, it was absolutely beautiful. The problem was that we couldn't have it throughout our architecture because it was just too risky, right? But we definitely could have wrapped it in a microservice and allowed him to do his thing in the places where it was appropriate. And that would have almost eliminated our risk, right? So this to me is probably one of the biggest reasons to look at a microservices architecture. As you start to get more granular services, as those services communicate to one another, now what you have is the ability and the flexibility to make technical choices that are best for your particular feature or responsibility. There's some other huge advantages here. One of them, ease of deployment, right? We talked a little bit about Docker and Kubernetes a little bit earlier. With those types of tools, it's all about the ease of deployment for things like container and these small little services that we're deploying on usually cloud infrastructure. And so that's a really important aspect as well. High scalability. If I've got a microservice that in and of itself, and we adhere to some really good architectural principles, I should be able to scale each one of those pieces independently. If I've got a small little service that starts to get overloaded, I can scale it up or I can scale it back depending on the load that it's taking. Because it's isolated, I have a much better feeling that when I start to scale that thing up, that I'm doing the right thing for my overall system. And that kind of falls into the resilience and flexibility, right? So we have all of these little autonomous services that in and of themselves are not coupled to anything else in our system. And now what I'm able to do is I'm able to scale it up or scale it back. If it fails, I may lose a couple features in my system, but I'm likely not to lose the entire system. Has anybody ever been on the receiving end of a failing SAP system? It just rolls globally, and it's just terrible. It's the worst thing that you've ever seen in your life. I mean, you'll have thousands of employees, and all of a sudden, SAP just starts to fail, and you just see lights light up right in your NOC, and the whole thing just kind of starts to fall apart. The whole idea is that with any particular microservice, if you've got a service that has failed or is failing, and you can't get it started back up, hopefully it's small enough, it has a single responsibility so that your entire system doesn't fail. So that's the overall idea. So those are some of the big benefits of microservices. What I would say in terms of issues with microservices. One of the big things is that the smaller the microservice gets, the more management overhead we've got, right? So you guys can imagine if you followed the single responsibility rule that we've done for years in the object-oriented space, and you created a microservice with a single responsibility, now all of a sudden you've got all kinds of deployment considerations because you might have 10 copies of that microservice sitting on 5 different servers, and you've got to manage all of that. You've got to inventory it. You've got to know where it is, what it's doing. One of the other downfalls are APIs, right? So you've got all of these little discrete services that are serving up information, and they have specific responsibilities. We've said that our programmers have a lot more flexibility. Well, if they're not following a disciplined approach in terms of how they modify those services and change their interfaces, now all of a sudden we have another inventory problem, which is basically what does that interface look like and how is it changing over time, right? So I've got a bunch of different people that are depending on that interface looking the same every single time it gets deployed, and now all of a sudden I've got a development team that can change it almost on a whim. Right? So those are some things that we have to solve for. The other side of microservices that has been a real issue has been deployment. Right? So I've got all of these different microservices out there, and I'm trying to have them run in their own process or their own space on my infrastructure. And the question is, how do I make copies or make instances of those things on the different servers? How do I deploy them out there? How do I orchestrate all of that stuff? How do I network them together? All of those types of issues. And so deployment, I would say up until the last few years has been a real issue in microservices as well. Okay? Any questions on that? I know I went through it pretty fast. I'm sorry, I'm kind of moving quick.
Do you think deployment for microservices is solved now?
I don't know that it's solved. I think it's much better. I think that with the open source tooling that's out there, like Google Kubernetes, for instance, I don't know if you're familiar with this, but Google's entire architecture is built on microservices. There's 70 microservices that get invoked in one search, right? And they deploy somewhere in the neighborhood of about 70,000 microservices or 70,000 containers a second at Google. So they're managing a tremendous amount of functionality and infrastructure through microservices, and they're doing it all through the open source project that they provide, which is called Kubernetes. I think that it's getting a lot better, and with companies like, Cloud Foundry, Docker, Google behind it trying to solve this problem, I think that we're going to see a lot of really good creative thought come out of it in terms of how to solve it.
Is that the next generation of their older Google buffers that they used to use to allow technology independence?
I don't know, but I'd be happy to check into it. But it's a great question.
That was their
I don't know.
original thing, was Google buffers was language independent.
Yeah.
And so you could use it across, since, we're a big Python shop,
Uh-huh.
and Java and so on, they use this internal architecture to communicate.
Yeah, I'm sure that it probably is. I'll take a look though.
So I have a question about
Yeah.
communication.
Yeah.
So in a high scalability environment where you have possibly 70,000 instances, what's the typical communication architecture? Is it a pub/sub type model? Is it?
Yeah, so that's a great question. So, so one of the things that I have not seen is I haven't seen, too many message queues or anything like that, like you'd see in a pub/sub messaging type of thing, right? Especially as it relates to microservices. One of the issues that we had with SOA years ago was that we had this thing, and I don't know if you guys are all familiar with it, but it's called it was called the n-squared problem, right? And it was basically where I had a service, and then I would connect that service to another service, and then another service, and then another service. And if you start drawing lines, you basically showing the dependence between that one service and all the others, you get what we call an n-squared complexity problem. Now all of a sudden I have to know about all of these other services that are out there. The pub/sub model, or a queue, a message queue or something along those lines, a bus, helped us solve that problem, because essentially what we would do is we would consume messages and publish messages to a message queue, and as long as the message didn't change all that much, then I was no longer concerned about whether or not my service was communicating to any other service, right? I was really kind of decoupling myself from that complexity, right? What I would expect to see, to your point, is that I would expect to see microservices evolve the same way, right? Because I potentially have a much bigger problem now. I have much smaller services, and which means that I'm probably going to be relying or drawing straight lines to a lot of different other services, and therefore, I probably am going to want to move to more of a bus type of technology or something along those lines. It's interesting to me that I haven't seen it yet.
Well, one might think that you would have another form of microservice that's acting as, the classic MPI2 type message passing that they do in supercomputers, or some kind of mechanism that essentially, I've done lots of large systems, and we usually have a couple of things up front that are essentially doing all the scheduling of messages.
Yeah, absolutely.
Things like that. So
Yeah, absolutely, like MQ series or something along those lines. And
I've done MQ series. There
Yeah.
are better ones.
Yeah, absolutely. No, yeah, exactly right. And I have seen implementations of things like RabbitMQ, open source message queues in this space, but largely simply to talk to legacy systems that are not yet inside their microservices architecture yet. And so it seems kind of funny that we're not deploying it inside of microservices. I think some of it is or deploying it inside the architecture itself. I think that some of it is that microservices are still very much a I hate to say a cowboy type of technology, but it's just now starting to get popular in larger enterprise development shops. The types of development shops that have been using Amdocs or SAP or something along those lines for years. So I think that as it starts to migrate into those spaces, I think that we'll probably try to solve the same problem the same way that we've always done it, which is to go to your point, we'd probably start to use queues or something along those lines.
Well, until you need scalability, though, you probably don't, right?
Yeah, but
And so-
you've got Google, you've got Gilt, you've got Netflix. I mean, those guys are all operating at scale.
But let's talk about 90% of the developers that are just using the cloud for.
True. Fair enough.
And let's not talk about WordPress, but
Yeah.
in a typical Docker type instance, let's say I had a PHP based microservice that essentially just returns some JSON.
Right.
What does the front end of that look like? So is it a standard URL with a port number? Is it
Yes.
a page
Yes,
ID?
Absolutely. It's a REST-based API is what it is. Yeah, exactly right. So and to your point, I mean, for most people that are not operating, at large scale, if they're using REST, then they're fine, right? They're happy. It's not going to solve the problem as the complexity gets higher. But for right now, if they've got a system with 20 or 30 microservices, it's manageable via REST. But that's correct. That's exactly what it is. It's a URL.
I have a question and
Yeah.
a comment. You asked about Google's protocol buffers.
Mm.
So they still use protocol buffers with a library that they've open source called gRPC. So you define the messaging layer declaratively,
I
and
think they
then
named it after you.
you define the messaging layer declaratively, and then you generate code for any of the target languages.
Yeah, that's how it used to be too.
And then you expose ports in Docker. But my question was, are you going to talk about things like service discovery and/or standardization of API interfaces across services?
You know what? I think that's a great topic, and I'm going to touch on it just briefly in terms of the tools. But I can't get into it. But you're absolutely right. I mean, that is one of the biggest issues that we've got, right? Is service management, API management, essentially, right?
Yeah.
So absolutely agree. All right. Any other great comments, by the way? Thank you very much. All right. Okay, so let's talk about some high-level best practices. To your point about in terms of implementing microservices. I'm going to use the overused metaphor of the three-legged stool, but try to dress it up just a little bit. When we talk about implementing microservices effectively, I'm going to kind of switch these around just a little bit. I started off with modern open source tooling with things like service management and those types of things. But I'm going to switch this around and I'm going to talk a little bit about a core set of architectural principles first. I think this is probably one of the most important areas of microservices. Then I'll talk a little bit about continuous process, and I'll end up on modern open source tooling, all right? But to me, these are the three legs of the stool that you absolutely have to have. These are the pillars of microservices that if you're not doing it this way, you're likely to fail, or fail the first time or the second time or the third time, until you start to address these areas. These three legs of the stool, I think, are important, and quite honestly, in the last 2 or 3 companies that I've started that have been development based, if I would have started with these concepts at first, with the thought process of creating microservices, even from the very initial stages, I think I would have been a lot more effective and a lot more successful in each one of those companies. And so this is one of the reasons why I'm putting this up here. There's going to be a tendency, I think, for a lot of people, to your point, we're going to want to talk about, large enterprise systems and those types of things, but we really need to talk about, companies that are much smaller in the startup stage and so forth, and really not only how they can benefit from microservices, but how they set themselves up to be successful in those microservices, because eventually they're going to get to a place where they need to do it, right? So let me just skip ahead here, and I'm going to go to the third leg of the stool, which is a set of architectural principles that I think make sense. So first and foremost, what I want to say about the architectural principles, like I said, this is much more art than it is science. And as a software architect for a number of years, one of the things that I've learned that is probably the most important thing about your software architecture is, number one, not to be married to the technology, and number two, be married to the organization. Look at the organization first, figure out what the organization has, what tools it has at its disposal, and build your architecture around the organization and the people, not the technology, right? And so as I go through this, I'm going to give you some suggestions or recommendations, but what I want to make sure that I really talk about is it's not a one-size-fits-all thing. You have to take a look at the organization and adjust the architectural principles based on the things that you can do. So what I like personally is, as a framework for architectural principle is the 12-factor app, or the 12-factor application. Has anybody ever heard of the 12-factor application? Okay. So the 12-factor app came out of one of my competitors, Heroku. The CEO of Heroku first put together the concept of a 12-factor application. And it has some things in it that are a little bit self-serving to Heroku because, Heroku has some limitations. But quite honestly, I think that it's really a very good and effective tool to set down a set of architectural principles. I'm not going to go through the entire list, but there's a couple of them that you guys are going to recognize right away that I think are going to be really important. To have a code base that's sitting in a version control system, like Git or Subversion or something along those lines, and do your deployments, do many deployments off of that same code base, right? Another one of the principles is simply making sure that your dev environment, your test environment, and your production environment are the same. Not close to the same, not sort of the same, right? So Django or JavaScript, right, with Node.js. I'm sure that PHP is this way, although I won't profess to be a PHP developer. Oftentimes what we do is we create in JSON, in Node.js, we create a package file. What is it called in Django?